Welcome. Now it's time to implement the image processor class. So our first question, we are going to implement the flip horizontal method, and it is right here. So the flip horizontal method, first, actually in all of the classes we have to first make a temporary image that we'll edit and finally replace it with the original image. So let this 2D array of pixels be flipped, what we call flipped, the new pixel of the width and height present there. Now we are going to iterate over this. So for r is equal to 0 till r is less than height and r plus plus, it will be a nested loop. Nearly always in a 2D array there are nested loops, and so it is going to be this. And finally what we have to implement, so our flipped 2D arrays particular row and column will take over the value our image has in its that same row, but the column would be width minus c minus 1. So let us now look what does it do. So width, so there will be some width, and when r and c will be 0, then flipped 0 0 would be image r0, that means the same row in our image, but it will take on the pixel value of width minus 0 minus 1, which is width minus 1, which means the last cell in the same row of the image variable. That is going to be the first cell in the first row of the flipped variable, and it will flip the image. It will keep going on and our image will be flipped. And last thing we have to do is that flipped, I mean image, is equal to flipped, and this method is done. Moving on to implementing the black and white image method. This actually, if you understand it, how an image is black and white, it actually becomes quite easy. So again, a 2D array of pixels, we call it black white, is equal to new pixel width height colon semicolon. Now a nested loop for r is equal to 0, r is less than height r plus plus, for like c is equal to 0 till c is less than width c plus plus. And the couple of statements are going to be, first we will compute the average is equal to image for that particular r and c. We are going to get the red out of it, and we'll add to it the get green and the get blue. So get green and we will get the blue, and that will average. After this we have to compute the average, so all this divided by 3.0 makes it, no, not 3.0, because whatever afterwards we are going to be storing, we have to store it in an int. So this will be an int divided by an int will be also an int. And now a new pixel called p be a new pixel, and as we saw in the constructor, it takes 3 parameters, and what we will give to it is our average value. So this pixel will be a shade of gray, and then bw r c will take on this pixel, and our pixel has changed. But just we have to do is that image is equal to pw, and this method is also done. Now coming on to the rotate left method. So this rotate left method has a bit of a math in it, but not much. Again, a temporary image, after temporary image, two nested loops, now type for the real code. Code will be that rotated CR to be equal to the image RC, and I'll tell you in a moment what's happening. Now look at here. Always whenever we made like a new temporarily pixelated image, it was like width height. Width came first, then the height, because first an array of width was created and then multiple array of widths were stacked upon each other, and then that gave the height of the image and we had the complete image. Now we here did the exact opposite, so it will be, its output will be something like this. And then look at this, for 0 0 it will be rotated 0 0 is equal to image 0 0. So what will happen, that rotated 0 0 2 2 will come over here, then this 10 10 20 10 will go over here, and then this will come over here, and similarly this will go over here, this will come in the middle, and this 0 0 will go in the middle. After all we have done this, all we have to do is that to flip the image horizontally, I mean vertically. In that we have our flip vertical method. And so once all this stuff has been done, we are going to come out of this loop. We are going to make image to be equal to our rotated one, and then we are going to flip it vertical, and this is also done. Now moving on to the rotate right. This we have to implement using the methods already present here, and if you got it, it is going to be rotating the image left. We will rotate the image left exactly 3 times to get the effect of rotate right, and that's it. It is done. It was just that simple. Yes. Now moving on to the get image size. Remember that the size of each byte is 3 bytes, and 1024 bytes make a kilobyte. So we will make a variable in bytes is equal to height multiplied by the width. That's the number of pixels multiplied by 3. These are the number of bytes in an image. Now kilobytes will be equal to these bytes divided by 1024. So if the bytes equals 1024, then 1024 divided by 1024 is 1. Then in that case we exactly have a single kilobyte. If this bytes is something like 2048, and 2048 divided by 1024 gives 2, then we have exactly 2 kilobyte. But what if it is at like 1025? Then 1025 divided by 1024, actually this is integer division, it will give 1 to the kilobyte, and that's 2. And the remaining bytes we will calculate by this, that now bytes will be equal to bytes percent 1024. So if we add 1025 percent 1024 will become 1, because the remainder is 1, and then bytes will be equal to 1, and this is accurate result. So we are going to return a string that size is, what is the size, plus kilobytes plus this much KB and plus bytes this many bytes. and we are done for this video also. Thank you.